biochar production technologies are already at the verge of becoming a player in Europe, I think, on the market. However, I think there is still some lack of trust and awareness towards green carbon production, green carbon applications, etc. And this is in particular something where we want to step in and support the whole branch. My name is Manuel Schwabl. I'm area manager at BEST Bioenergy and Sustainable Technologies, and I will show you today some results from a survey we conducted for our Ministry of Climate on European technology, pyrolysis technologies in Europe, as well as some glimpses on our quite unique green carbon lab facility we have here in Austria. But first, some words to our premise. BEST Bioenergy and Sustainable Technologies. We are aligned in 3 different areas. One is dealing mainly with technologies and technology developments, with the focus of production and optimization towards green gas, green carbon products, but also biofuels, and opening up the possibilities for new resources. On the other hand, we are supported always by our wing body. I call them our wing buddies because they support us on a digital world by process simulation, automation, and control, or very holistic also with microgrids and smart energy communities in order to fully enable the advantages of our biorefinery technologies. And all over, we have a cross-cutting area on sustainable supply and value cycles, focusing on the impact assessments of our technologies, doing full-scale life cycle assessments, as well as techno-economic analysis. Therefore, we are looking for a deep climate negative impact and support circular bioeconomy strategies, using in particular our unique research and development infrastructure we have, which ranges always from very lab scale to pilot and demonstration scale, which we have on the one hand for in pyrolysis technology with our green carbon lab, where I will come to that later on also. Then we have a syngas platform in Vienna, which is a 1 megawatt gasifier system producing synthetic gases from biomasses, residues, and waste fractions. And downstream, we have also connected 1 barrel per day Fischer-Tropsch synthesis, capable of producing kerosenes, waxes, etc. And then we also have in lab scale other synthesis technologies like mixed alcohols in a lab scale. We also have a similar approach in our bio and microbiological conversion technologies, where we have different fermentation systems. And last but not least, we also have a microgrid lab combining individual bioenergy technologies, but also CHP technologies, photovoltaics, as well as battery charging stations, etc., to test in particular different holistic control systems for such microgrids. Yeah, as such, therefore, we see ourselves as a one-stop shop for technology R&D with process innovation, process optimization, and support in automation and control, as well as if you come to a product development until a risk assessment of the total of a total system. This we do in particular always together with feasibility testing of different value cycles from, as I said, from lab to pilot scale. So, but now I want to go more into the topic, more into our project results, and show you some sneak preview results actually from our technology survey we conducted for our Ministry of Climate. Just as an overall where we gathered all our data. We sourced companies in whole Europe on pyrolysis technologies, where we found over 400 companies dealing with all different kinds of pyrolysis, from fast pyrolysis to small, and also retailers were contained. And in a second step, therefore, we selected technology companies which focus more on intermediate pyrolysis, which focus more on decentralized application, which means also having a maximum feed input flow of about 500 kilograms per hour. And of course, they should be a technology provider and a manufacturer and not only a retailer. After contacting, we did overall 22 interviews with these technology providers, resulting in a final overall technology overview of 19 different technologies. Where did we find now in a European scale all of these technologies? Actually, we found quite a hotspot in Central Europe. So the main technology providers, technology manufacturers are actually located in Germany. 9 out of these overall 22 interviewed company partners were situated in Germany, but also 2 companies were situated in Switzerland. And then we had a couple of all ones, always a single company in Great Britain, Poland, Czech Republic, and Austria. And here displayed in green 2 are countries where we found also technology providers, but they were not responsive to our survey, unfortunately. Now, let's dig a little bit more into the technology details also. Actually, we found that it is quite a broad diversity of technologies all over Europe. And this diversity is displayed not only in the feedstocks, but also in capacity. And then we see later on in products, as well as in technology itself. And last but not least, also in the technology readiness level, in their R&D level, which they are at the moment. Looking a little bit on the feedstock itself, most or actually all of the investigated pyrolysis plant manufacturers focus actually on biomass like wood chips, but also husks like dinkel husks or wheat husks are a topic to them. And the second most interesting feedstock was inhomogeneous biomass like from road thinning or screen overflow from the composting. Also very exotic ones were in this survey, which investigated or do pyrolysis of plastics or special wastes like tires and MDF. Concerning the capacity ranges, where we of the companies we investigated, they range from very, very small scale, a couple of kilograms per hour, up to more than 800 kilograms per hour. And up to 500 kilogram, we envisage actually those companies which deal with decentralized application of such technologies. So it is also a very broad range, a very broad diversity. Looking on the product side, all of the investigated producers focus actually on the char production. That's also why I'm invited for this talk today. We are talking about biochar and green carbon products, but coming to that also later on. The second most interesting product is also heat. And only a couple of them actually focus on additional CO2 certificates or on wood vinegars or pyrolysis oil products which they commercialize. From a technology point of view, most technologies focus on screw reactors, but also vertical flow bed reactors are quite often named here. And last but not least, rotary kiln system. More exotic ones are moving bed or grate systems, as well as belt reactors, actually. And also within our survey, we included 3 semi and discontinuous batch retort systems, which operate and produce the biochar in such retort systems, and therefore not continuously. So now coming more to how does the market look like, how developed is the market at the moment, we see that only 4 companies actually have more than 10 reference plants installed at the moment in the European market. And all the other company partners have up to 4, but the majority actually has 0 to 1 installed plant out in the market so far. This shows that we actually have quite a dynamic market at the moment, and we are going to rise or increase the sales in the upcoming time. But what does it mean also in terms of specific investment? All this diversity from technology, from low tech to high tech, from screw to different feedstocks. We asked also for specific investment costs, actually, and we found out that these range from very small scale, only a couple of thousand or only 1,000 euro per kilogram per hour, ranging up to actually 10,000 euro per kilogram per hour of specific investment costs. This shows in particular how diverse the market is, as I said, from low tech to high tech, from different technologies and different feedstocks. But it also, we did not see any correlation also to the capacity of the system. Now we took these investment costs and we did some very preliminary economic analysis, and we compared it actually with combustion technology. I don't want to go into detail because I think the time is too short for it. I want to show you also some additional results on other topics. But it shows that integrating heat as well as CHP has economic benefit from cost to revenue point of view, but it is very limited. Looking only at a pyrolysis system which sells up to 50% of the heat, we account approximately a revenue, an annual revenue of about 6,000 euros per year, which is very low actually, and not comparable to similar combustion plants with heat or with CHP systems. Therefore, we investigated also different kinds of influencing mechanisms on this economics, like energy integration level. The 50% heat integration level was our standard case, actually, and we checked if we could integrate all of the 100% of the produced heat within pyrolysis system, knowing that not all of the heat is generated, and partially it is retained in the biochar, of course. But still, if we could valorize 100%, these revenues skyrocket actually up to 100,000 euros per year. If you, on the contrary, if you do not sell any heat or any energy, you might have a significant loss with your technology. In a second parameter study, we investigated different feedstock qualities. Here we saw the major impact actually in the feedstock quality. For example, dinkel husks, which have lower densities, in order to operate the system. You are confronted with lower product output of the system, resulting in a lower economic revenue, even though that the product or the feedstock costs are actually significant lower as in the reference of wood chips. And last but not least, here you see results from road thinning. At least in Austria, road thinning is declared as waste, and therefore you cannot sell any waste resulted biochars to customers actually, which is missing totally in this revenue stream and resulting in such a big annual loss. Last but not least, we investigated if you could have an additional revenue valorizing the CO2 certificate. And took here as a reference, again, here you see this, the wood chip system from the beginning. And if you can valorize your CO2 certificate with additional 50 euros per ton of CO2, you can actually increase significantly your revenues of your technology. So to sum this European pyrolysis technology survey a little bit up, the market itself is very diverse and highly dynamic. And I think the energy integration is very crucial in order to become economic in particular. Into the dimensions concerning net zero energy technologies as well as on the economics. Most probably you will need also additional CO2 certificates for the products, which are also available at the moment already, and for the commercialization of such technologies, I think it is necessary. Also, because the market is very dynamic, I think the technology costs of such pyrolysis technologies will definitely improve in the future, and therefore I think that the market will grow significantly. In order to, that is, as I said, just a pre-release of these results. If you want to receive our report on that findings, please register on that link also. We will send you the official report of the Austrian which was approved from the Austrian Climate Ministry directly after the release. I see I have a couple of minutes left now, and I want to go a little bit more what we are doing with our Green Carbon Lab, which was actually funded under the EFRE funds from Lower Austria. The Green Carbon Lab consists of three different types, three different scales actually. Starting with analytics and characterization of different processes, feedstocks, as well as products, having very unique facilities in our laboratory. And then it is coupled with two pyrolyzer units, which I will show you also here. One is a laboratory pyrolyzer unit on a rotary kiln, and then we have a pilot pyrolyzer unit. And all of these allow us to do feedstocks tests with different kinds of residues, as well test different kinds of temperatures, residence times, and therefore produce product qualities of green carbons for different kinds of applications, which could be steel industry, but of course soil amendment, or also we tested, for example, composite materials in plastics. So how does the facility really look like? As I said, we start from a very small scale laboratory system where we have a TGA capable of different atmosphere, and it can be coupled even so the gases extracts, the gases compounds can be analyzed with FTIR in order to analyze in particular the reaction kinetics. Then we have a single particle reactor. You see it here at the bottom, where we can investigate the pyrolysis on gasification of a single particle. It is also put on a scale where we can see how the process itself evolutes over the time. And then we have a couple of lab reactor systems. One is simulating a grate system. And then we have a laboratory pyrolysis unit, which is a rotary kiln, as well as a pilot pyrolysis, which is a double auger system. I will go through that rather fast, actually, to show you also here. You see the laboratory pyrolysis unit, small scale, 0 0.5 to 1 kilogram char per hour production, and up to 1,100 degrees centigrade within these rotary kiln. Then you see here the pilot pyrolysis unit, which is a double auger reactor production rate of about 25 to 30 kilograms of char per hour, and reaching temperatures from 300 to 800 degrees C actually. What I wanted to show you also is here some first feedstock tests we conducted in our Interreg Alpine Space project, investigating, of course, wood chip. Always we utilize it as a reference to check and compare it also in particular with combustion applications always. But we checked also walnut shells as well as compost screening from overflow, for compost screening overflow. And here we had a special focus on what you see here in the middle of the picture, these leftovers from the bio-based plastic materials and how these materials behave during the pyrolysis process. Also very interesting was wheat bran, which we received from our local sugar producer. Very interesting was actually that wheat bran has a very low ash melting behavior. It is about 500 to 600 degrees C, where the ash starts melting. And during our pyrolysis tests, we actually had quite some issues because it became sticky. So the biochar itself became sticky. And we estimate now in the meantime that it is actually because of that really low ash melting behavior that it starts already at the edges of the biochar to sinter and therefore to connect with the next biochar particles. Also a very interesting feedstock is coffee chaffs from the production of coffee itself. You see here also even the coffee chaffs themselves, they are briquetted during the manufacturing process, and even after the pyrolysis process, they maintain actually their shape, which was very interesting. Last but not least, also some sneak results or sneak interesting information. Today we had our kickoff meeting on our green carbon for steel project actually, where we have our local or national steel manufacturer, voestalpine, as well as a very international plant manufacturer, Prime Metals Technologies, and a local pyrolysis technology manufacturer, NGE. And some preliminary information here, what they told today, they are actually in the need of 15,000 to up to 250,000 tons of biochar per year in only one site in Austria, actually. And this is actually calculated back. So even their foreground is not to substitute their fossil coal needs within the steelmaking industry. Actually, even if they also, when they transition to hydrogen production or power production, power produced steel, they always need a certain amount of carbon actually in their process, and in many directions. And the one direction, of course, the steel itself contains up to 4% of carbon. On the other hand, the process itself needs for the electrodes as well as for the slag foaming abilities, a certain amount of carbon in the process. And here they want to introduce biochars and green carbons into their processes. Major requirements to that green carbon is in particular, and here if you compare it directly to the anthracites or the fossil coals, is it has a significantly higher reactivity. So they need to bring in the biochar until the melted metal, which is quite an issue. The anthracite itself is not so reactive, and it simply pops on the surface of the melt. but the biochar, if you introduce it, it is already converted in this yeah, in the upper region of the furnace, for example. Additional requirements to the green carbon are for sure also volatile, as well as the heating value itself. And here, therefore, the biochar production process is really necessary to be understood. How different kinds of feedstock can be produced with these requirements, which are necessary for the steel industry. So this was almost my presentation. As I said in the beginning, our role is actually to support the whole sector and to pave the way. And we are here for the whole sector with our unique R&D facilities. And I'm very open also to your question. And thank you very much for this opportunity today.
Thank you very much, Manuel. Yes, hi. Thanks for the presentation. And so to the audience, if you have any questions, please start writing them into the chat. My first question was, so how long does the Green Carbon Lab exist yet? So how old is it?
Well, it is, we came into operation in May this year.
Okay. Okay.
So it is really freshly procured. It was procured within 1 year, actually, which was quite challenging to us. But we are very happy to have it right now, and it is ready to operate and ready for feedstock testings.
I was just wondering because I've never heard of it before, so and that would be a surprise to not know that if it's older. So the first question was more a question for later. So if you can put the research URL into the chat after the presentation, so they can just directly link to that. So then Rand was asking, how pure does the biochar need to be for the steel industry?
I think the purity itself is not, they have not so strong requirements. What they said, they have certain requirements concerning alkali metals, as well as phosphorus. But in terms of ash content, they are quite open, or it depends also on the process where you want to implement it. It is different if you want to introduce it in an electric arc furnace, or if you want to use it in this Hochofen process.
That directly runs into the second question from Christian Wied, who was asking, do you think sewage sludge biochar could be used in the steel production, especially with a 6% phosphorus content?
Well, I think that's the main issue, actually. As far as I remember, they said today it is 0.09% phosphorus, which they allow.
Okay, so basically
it's way off. So sewage sludge from municipal communities, no, I'd say. But there are other sewage sludges too, which I'd say, for example, from sugar manufacturing, I think it could be possible. They have really high calcium issue or calcium content in the sewage sludge, but that could be possible, for example.
And just a question from my side. Do you know what the price they are targeting for the biochar biocarbon to be relevant for them?
That's a really good question. Well, I think they said today that with a price per ton of about 500 euros per ton and logistics costs from America still, and taking into consideration, of course, ETS price, so the CO2 pricing, they are compatible with a fossil coal from Poland.
Okay, so that is actually not too bad for the European biochar sector. I mean, we are still a bit over that, but it's getting there. The next question was from Gabriel Batista, who was asking, beside pyrolysis, are there other thermochemical conversion technologies in the scope of the Green Carbon Lab, especially hydrothermal carbonization or hydrothermal liquefaction?
Not within our green carbon lab, but we're thinking already about coupling our green carbon lab to HTC, hydrothermal carbonization processes, which has of unique abilities in particular, but you always need a pyrolysis step, most probably after HTC production. For this coupling, we have partnering institutes, for example, like BOKU, where you were from actually, Christian. So we might connect also here for cooperation possibilities.
Okay, and I also had one more question to the technology survey. So because you calculated the economic revenue, what is the
Yes.
biochar price you assumed?
The sales price we assumed was actually 700 euros per ton.
Okay.
Quite high.
Okay. Yeah, I mean,
But we
it's
needed to
current price.
yeah, it is a current. We took some of the current pricings exactly, but the question is if somebody buys it with that price.
Yes. Yeah, that's true. Okay. Thank you very much. So we are perfectly on time with your presentation. Thank you, Manuel.
Thank
If
you very
there
much for